Good day, everyone, and welcome to today's webinar, Improve Manufacturing Throughput with Predictive Quality, hosted by the Industrial Internet Consortium and IoT Solutions World Congress. My name is Vinicius Stray, and I'm an industry consultant at SAS. We are delighted that you are joining us today. Before we get started, let's go over some quick housekeeping. We will have ample time for all of your questions today, and we will answer them at the end of the presentation. Please submit your questions by typing into the Questions tab on your Livestorm dashboard. Today's webinar will be available in video replay at the conclusion of the presentation and will be emailed to all registered participants. If you'd like a copy of today's presentation slides, please download them from your webinar dashboard. And now it's a pleasure to introduce today's webinar. So before we get started, I would we have David Petrucci with Microsoft here with me. David, would you mind introducing yourself and sharing a few words?
Yeah, thank you, Vinicius. Yeah, my name's Dave Petrucci. I lead our business strategy for our manufacturing vertical and grew up in the quality world at Honda, and just looking forward to this conversation today.
Thank you, David. So in this webinar, we're going to talk about manufacturing quality today and some trends. We're going to talk about the impact of cloud and analytics leading to a more predictive quality. Then we're going to share a couple predictive quality examples. And regardless of the industry that you are, could be discrete industry or process industry. So this presentation is applicable to you. Throughout the years, I've seen so many problems. Could be in the manufacturing side, the discrete side, 6-7 figure parts being scrapped, sometimes due to a small quality problem. Could be like an overcutting because of wrong coordinates. Or process industries, we can talk about vinyl chemical operation or steel operation, where you sometimes don't meet chemical or metallurgical properties on the material, and you have to recirculate material in order to achieve your specifications. And then at the end, like I said, we're going to have closing and Q&A. So let's get into it. So talking about manufacturing quality. So the focus of quality traditionally in the manufacturing space has been around detection and investigation of quality problems. So whenever a problem happens, right, someone has to kind of go back and see what the root cause was and investigate, if a problem has happened or not. And probably some of you guys are in global companies, global organizations. You are bound by many local, national regulations or market-specific regulations or standards. And that's why the quality space is very process intensive. So probably the number one task you have to consider when we talk about quality, and this is just like a simplification, quality is much broader than this, is in terms of quality management processes. And those processes, they are going to define how you're going to test your parts, finished or unfinished parts, how you're going to do inspections, how you're going to record this information for product traceability in the future. It's very important from a quality standpoint that should a problem happen in future, a product that was already sold to your final customer, that you can go back and trace the genealogy of that part or that product in order to determine how to minimize this problem in the future. And we also see the quality departments and the quality sector is a major driving force in manufacturing organizations for continuous improvement. If you compare, for example, the OEE cornerstones, availability, performance, and quality, traditionally quality is the one that performs better. That's usually due to, let's say, this continuous improvement spin that quality drives. So if I were to summarize today quality, I would pick those four aspects in order to represent how quality has been structured to do, let's say, better detection and investigation. But if you look at the title of this webinar, we are going to talk about predictive quality. How can we move from detection and investigation to a more, let's say, predictive aspect of quality, that we can eventually determine if a batch or a product is going to be good or bad before we start the process, or during in-process quality control. There are various strategies that we can use in order to do better predictive quality. And I'm going to just describe, one of those strategies that to me is probably the one that's achieving great results in manufacturing. And I like to call it quality analytics. Analytics is all about gathering data, gathering information, and generating insights from that information. And I want to talk about three aspects here today on how quality analytics can empower better predictive quality. The first one is quality ecosystem. So quality traditionally is very siloed. So we have information all over the place. So how can we leverage all the internal departments and sometimes external parties, could be your suppliers, partners, and customers' information in order to achieve better quality? The second one is connected quality hubs. We know that manufacturing traditionally, probably in the past 5 years, is facing tremendous human resource constraint. So even before COVID in the United States, we were facing, let's say, record employment. It's hard to find talent. And now in this post-COVID recovery, it's becoming even harder to hire quality talents. So how can we leverage data analytics and quality and the data or the power of the cloud in order to bring the quality information to the quality experts wherever they are? So they could be in North America supporting operations in Asia, South America, Europe, and so on. And the third aspect that I will drill down later is about quality models. So traditionally in the industry, over maybe 5,000 years, we've been modeling quality processes. For the most part, we are using the laws of physics, right? So we know, how systems behave, could be in terms of heat transfer, mass transfer. But those systems over the years, they are becoming increasingly more complex in order to achieve the product specification that we want to achieve. So we got to look into new strategies, and some of those strategies are data-driven to build better quality models. Looking into the past, 30, 20, 50 years worth of manufacturing data, and how can we derive better models with that? Over to you, David, to share your insights on this topic.
Yeah, Vinicius, that's great, setup. And I think there's two areas I'd like to drill down on. And, when we talk about quality ecosystems, let's face it, there's only so much control you have within the four walls of a plant around quality. And there's the resource, capabilities there, but there's suppliers, there's other things that are, engineering that sit outside the four walls of the plant that you really have to think about this quality ecosystem and how you build that kind of remote capability for that ecosystem. And I think there's two layers that come together here, and it's that connected quality hub and it's that ecosystem. And how do you use that quality hub to build the insight, to share, communicate, and collaborate? And how do you build that collaboration model from the ecosystem so that you can get more real-time input? Part of the biggest throughput issues with quality is you're always waiting for an answer from somebody, and everything's frozen until you get that answer. And that's either you take a bunch of parts and put them off to the side, or you stop production, you start sorting, whatever. But you're always waiting on some type of information from typically some external resource. So how can you get that to be more real time? How can you get subject matter experts that might be sitting at headquarters to be able to review something very quickly and give you immediate input to make decisions on? We see this with numerous customers where they're building this shared services model where the SMEs and the experts sit centrally and they support many sites, because you just can't put your experts everywhere anymore. They're too distributed of sites, there are too many locations. So these two concepts coming together, I think, really have the transformational powers to change how we look at quality, how we deal with quality. And by the way, quality's cool again. For some reason, after 15, 20 years, quality's top of the conversation list again, because as you said earlier, resources are constrained, and first pass yield, these types of things are so critical to the conversation. So back to you.
Yeah, like David mentioned, it's not really easy to get the right experts, in the right place at the right time. And I would say the number one challenge that we see in manufacturing in terms of achieving better quality is the data fragmentation, right? There are just way too many systems, way too many databases, way too many locations is storing quality information. And the problem that we see is sometimes you do get to some quality results, but I like to call them local optimum results. So it's probably not your global optimal result in terms of quality. And I can give you another example. It's also very common in the industry in terms of cosmetic finish. I'm sure some of you have coating or painting stations. Let's say that you're having cosmetic issues on your parts, and you want to determine why you're having that. Sometimes you're going to have to look into the SCADA information. And in the SCADA system, it's where you're going to be storing information about the cycles that you ran with your robots or your coating booths or your personnel. You're going to have to look into the MES information, where you're going to have the order information, how long the painting process took. You're going to have to look into your ERP information, because that's you're going to have the information from your supplier about the painting or the coating that you bought for that activity if you have multiple suppliers. So when you combine all this information, that's going to empower better quality analysis. So, but when I say that data integration is required in manufacturing, I'm not saying that you have to take a big heavy lifting and start connecting systems into a single pipeline at once. We usually like to say that it's a step-by-step process where you identify problems and goals, and you say, hey, I do have a quality problem here that I could definitely leverage some better data integration. And then after that, you derive your analytics requirements. Analytics requirements in terms of variables that you think you should monitor and the outcomes that you want to achieve. So what are my outcomes here? What kind of problem I want to resolve? And then you start thinking about the data infrastructure. You know, what data sources should be connected and so on. What kind of personnel should be involved? That's also a very important topic. It's not only a quality department discussion here. We are talking about operations, maintenance, sales and operations planning, and so on. And then you're going to think about how to generate better predictive models. And when I say generate predictive models, is look into the past, look at maybe 20, 30 years worth of information when you had bad, good batches, bad, good product, bad and good parts, and start deriving some conclusions on that allow you to extrapolate for a result in the future once you start running new products. And then you're going to measure results. And by measuring results, that's going to give you the depth and, let's say, the experience to pursue other projects. So by gathering information, by connecting the data, by gathering the data, because data doesn't drive transformation, then you're going to start generating insights. And those insights, they're going to allow you taking better decisions. When I say decisions, is not necessarily make automatic changes to your control systems. Could be just give recommendations to your quality department how to improve the quality operations, or eventually give recommendations to your operators, who are running the factory, so they can eventually reject a batch, reject a product, or approve a product, or approve a batch. And once you have those decisions in place, that's when you're going to have the impact in the bottom line. David, would you expand a little bit more on the impact and the decisions here?
Yes, and thank you. This was great, great capture of what the real world looks like. And over the years, we've built this very large pyramid of information systems in a factory, and these are things that we consistently look how to simplify, how to consolidate as we move forward into the next generation of manufacturing. And I think the key piece here is insights to action, right? And how do we not only capture the full view of what's happening in a manufacturing operations, and that's not intended to be a multi-year integration strategy. This is how do we get core pieces of information that run across our manufacturing process, identify the insights coming from that information, and then quickly take action about that. And I think that's the important thing here is don't try to complicate or over-engineer this process. Start getting the information. Let these intelligent quality systems actually tell you where to focus and how to focus, because we're all constrained on resources, whether it's at the production employee level, whether it's at the engineering level, whether it's at the quality tech level. We're all constrained and have too much to do. And these systems, these intelligent systems, can help you focus. And I always tell people that use the information to tell you where the hot spots are and manage the hot spots, or manage what's becoming hot spots. And don't worry about trying to manage the entire system, because we just don't have the capabilities. And that's what these, next wave of systems really allow us to go do as we go forward. And this ties into the impacts of, good and poor quality as we go forward. So when we talk about this, what is the impact? And, we look at the traditional scrap and rework. We look at the underutilization, or in some cases when you're playing catch up, overutilization. We talk about warranty costs. We talk about lost sales. But there's one other piece here that I have found has become actually the largest contributor to cost of quality, is morale. And there's nothing more deflating to, production employees when they know that a machine, a system, a process is constantly turning out poorer quality than it should. And yet nothing's being done about it. Engineering isn't fixing it. Maintenance doesn't know what to do with it. And it's just continually putting out lower quality product than it should be. The other thing is that we spend so much time calculating OEE and equipment performance. We don't look at, the fact that most of assembly work is still very manual and done by an employee, and not necessarily how we're rating or ranking an individual, but how is the performance at that site, at that cell, at that workstation? And what are we doing to help improve that output of that workstation? Because these are all really critical, and we're in that world of constrained resources like we've talked about so many times today. And we're just not going to get more people anytime soon. So we need to continue to drive quality, to look at that throughput rate, look at that first pass yield, drive that morale, which eventually drives the brand image. And so this is where these systems really can have an effect. And cost of poor quality, I think we sometimes really underestimate the value of cost of poor quality. And I think the numbers would show here between 5 and 30% of gross sales. But in many cases, I think it's a much higher impact on that, because there's some things here that are harder to measure, that are more the soft side. And so this is why quality is so important today. And I think, again, I'm glad to see the refocus, and everything that we look at is really about, how do we improve quality today from an investment standpoint with our customers, and how do we make it more intelligent? We all have known the manual inspection, visual inspection has been at best 70%. I think is the usual going rate, and we just by doing it twice doesn't make it that much better. So how are we using the vision systems to get more precise? How are we capturing that in these analytical systems to understand how we improve those processes? I can't underestimate the impact of quality. And with all the senior executives I've spent in manufacturing over the last few years, this combined with the lack of resources from a human standpoint are the two things that they just constantly talk about. And I think most have quality metrics in their plants and they're managing those. But the other thing we found, and this goes back to the quality management systems, are there's quality metrics for, I'll say, financial metrics of coming from either people's performance bonuses, metrics, et cetera. And then there's real performance quality metrics that matter. And I think you're seeing more and more companies go to what are the quality metrics that matter for the plant and for the real quality of the plant, and making that shift to make it more meaningful. And so this is such a great topic. And I think, The systems today, these smart quality and intelligent quality systems that are out there are really a driver to what's next for us. Ignatius, you want to talk about an example?
Yes, absolutely. Thank you, David. So I just want to add some color to this conversation, and I hope David and I, convinced you that predictive quality is important. But I mean, how we enable predictive quality? I think I probably won't be able to answer this question in very detailed fashion here, but I feel like I can give you a glimpse what this process would look like comparing to how it's done today. So this example, before I get into it, take a look into this one slide, right? At the end of the day, what we want to build in an organization are two things: a data pipeline. And this data pipeline, you're going to have multiple swim lanes. And one of these swim lanes is going to be the quality information, right? You're going to get quality information from quality department, from your operations, from product engineering, from logistics, from suppliers, from all the stakeholders that are engaged in the quality process. And probably some of the databases that I explained to you in the past. This is not going to be a 1 year, 2 year endeavor. This is a long process that you're going to engage. But at the end of the day, once you have the information in one location, this is not relevant only for quality purposes. This is relevant for all the operations that you're running. And the second pipeline I want to highlight here is the analytics pipeline. You don't have to have all the data in one place to start doing analytics. But once you have your data operations let's say in a good way, in a good place, in a good shape, that makes so much easier to start doing analytics. Let me get into this example. So let's pretend we are let's do an exercise here. So let's say that your sales and operations planning just received a new order. Could be an order from a customer, let's say like a custom part, a custom product, or could be, let's say, a product that's off the shelf, right? That you have to plan for the next month, how you're going to make that order, because you have some commitments to your customer in terms of dates. So the first thing they're going to do, right, once they get a new order, is look into what are the expected product specs. Probably this information are going to come either from your customer, or you already have that, depending on the order that was placed. Could be like a part number. You already have this information in your ERP or in your MES system, and that's going to be downloaded to your operations. I'm going to stop here because that's usually how it works today, and I call it open loop manufacturing. You're getting orders. You know what you have to make. And then what happens in the companies is that they have those heuristic models, and they use those heuristic models to change control settings, to implement changeovers on the shop floor. And then at the end of the day, you just hope for the best, right? You do have a very good sense on what settings, what process settings you have to implement in order to deliver that product. But at the end of the day, right, there are disturbances in the process. Those disturbances could be related to your feedstock, raw material that you're buying, could be related to some degradation or changes in the manufacturing equipment. We know the manufacturing equipment changes over time. And at the end of the day, if you sum all those disturbances, all those situations, all those minor deviations, that might lead to a quality problem at the end of the day. And what we want to implement here is some closed loop manufacturing, where you're gathering a lot more information to minimize the quality problem. And I'll give you just two examples here of information that you can incorporate. First one is the raw material specs, right? Wouldn't it be powerful, for example, what you're buying from your suppliers, right? You know that you have a range of a specification for, could be chemical properties, physical properties, and you work with that range. Sometimes we just don't take into consideration what is the actual value, if it's close to, let's say, a upper threshold, a lower threshold, but at the end, that's going to create some quality problems to certain markets. The second component I want to add here, and those are just two components of this quality decision, proactive quality decision, is the current process conditions. Sometimes you're running certain batch before the one that's coming, and the process conditions are not going to be the same. Even if you have, let's say, a 2-hour changeover, 1-day changeover between batches, the current process conditions are going to affect the outcome of the next batch, right? So once you start taking all this information that you have available in the manufacturing floor, and you start running models, that's going to create better quality outcomes. So that's here. So once you have all this information, you're going to start executing the models that you built. And those models that you built based on information that you have in your data pipeline, they are going to give you the analytical insights. And those analytical insights could be various forms and shapes. So it could be some expected quality recommendation to your quality department. For example, hey, there is a likelihood, 80% likelihood that this product, this batch, or this campaign, or this part is going to be a bad part, so please take some action there. Or it could be in form of some automatic feedback to your control system, to your DCS, to your SCADA systems, or to your operators, in order to change some control set points to let's say, compensate or offset those perceived quality risks. It could be even in process or before you start running a new batch or a new product. So, and that's I mean, I shared this specific workflow because that's really what was done for this specific customer. And this customer was a leading producer of building materials. And if you know building materials, it's a very challenging environment from, let's say, business standpoint, because you do have your corporate customers, or you're selling, for example, directly to builders, but you're also selling to wholesale, you're selling to Home Depot, you're selling to Lowe's, you're selling to Walmart. And if you have bought building materials in the past, you know that you go to those department stores and you have 20 options to pick. And cost, price, is a major driver here. So if you can save a couple cents on the dollar by minimizing the cost of quality, that's going to lead to buying decisions from your end customers that will eventually prioritize your customer. And that was the situation here, where this specific customer was having problems. Before they implemented this solution, it took them maybe a couple days to determine or try to infer what the quality outcome is going to look like. By having better models, predictive models, they were able to shorten this time to right before they start a batch, or even during the batch, so they could anticipate potential quality problems. And at the end, this project evolved to, let's say, an optimization problem, right? How they could optimize their formulation based on the raw materials to achieve the product quality they wanted to achieve. And at the end of the day, right, you start saving downtime. You have, you save in terms of waste. You don't have the same waste that you used to have, and that impacts tremendously, the company result. So, David, any comments?
Yeah, and I think of, real world experiences, beyond this example, I see all the time. And I think there's two lenses of the world right now where there's traditionally so much M&A activity that goes on between manufacturers, and I'll say either site consolidation or site transfers or line movements. And we all know the history, and this kind of goes back to your previous set of slides, where we talk about engineering specs, we talk about even BOM routings, and 99% of the time, anytime I do a movement of a line, or I do an acquisition, that whole set of specs is usually wrong. It's never been updated throughout the years. It's never been managed well. And so, who's ever accepting that is going back through requalification. And there's so much that can be done with, predictive quality systems and quality insight systems that allow you to at least put the benchmark on, hey, what's the reality of this line, and how can I use the analytics to tell me, hey, the routing actually should be this time, or it should be this spec. And so there's so many ways to use these new kind of quality systems and predictive quality systems that you can think about. The other is, so much of the world is contract manufacturing, which is really a black hole to most end customers here, or most manufacturing companies. And how can you prescribe more, I'll say, integrated predictive analytics systems that sit within your contract manufacturer to start providing you more input and insights on your larger supply chain and how that can be affected. So there's many ways of using these systems, and I know you have a couple in here. But the other key piece you made was talking about what I called earlier, that insight to action, and that action being really more of an autonomous approach of, call it self-healing, call it whatever you want, but being able to take that predictive analytics feedback and tying that back directly into more of a closed loop process of adjusting equipment, modifying settings, et cetera. And that used to be, I think, interesting conversation 5 years ago, but we're seeing that done every day at our customers today. And I think that's really where this starts affecting, is when you really take that insight to action and you actually take action on it, and not just record it, but actually take action through more autonomous environments. And I think that's the real opportunity and where this goes, next.
And I just want to share another example with you all, because I talked about existing data in the shop floor. And I want to say that sometimes, depending on the quality goals that you want to achieve, you just don't have the inputs readily available in order to determine quality. So sometimes you do have to rely on new strategies, and this is just one strategy, and we call it artificial intelligence of things. It's just like a flavor to the Internet of Things, right? So in this example, right, you're going to be relying on new IoT sensors in order to determine quality. So it could be, for example, a problem that you're trying to map quality, and quality could be quality/performance or uptime, that depending on the characteristics of your equipment, the best suited variable that you could monitor could be like a rotary equipment. Is going to be based on vibration. And I give this example because I'm sure most of you or some of you have already engaged in this process, where you have to start, instrumenting your manufacturing equipment in order to achieve, or collect information that's going to allow you to derive better insights. So in this case, it's very similar. We get a new order, we have an expected product specs, but how to get to this is expected quality outcome that you're going to determine if a part or a product's good or bad. You're going to have to start putting some IoT sensors to complement or augment the information you're already collecting from the plant, right? And when we say artificial intelligence of things, just to finalize here, is just kind of bringing the human brain capabilities, cognitive computing, down to the shop floor. It could be down to the edge device level, where you're installing a sensor that has high capabilities to identify certain patterns in production, or it could be up to the cloud level or the factory level. Okay.
And that's interesting, Nishis, because I think we always thought about that being hard and how to go resensor or add sensors and the cost of it, the time of it. I got to run wires. Today's environments, we can very easily put gateways in. We can very easily, add sensors at pretty minimal cost. And, typically through some type of wireless environment, you're not having to run cords and things of this sort. So, this again has, I think, simplified immensely over the last few years, and from a cost standpoint of implementing, it also come down, extensively. And then, again, feeding that right into a cloud environment where you can have centralized analysis. Those are all easier to do than they were just, a few years back.
Exactly. That's a good point, David. Yeah, I mean, the cost has been going tremendously down. So I talked about vibration sensors, and I recall the day 10 years ago that a vibration sensor used to cost north of $1,000. And now we do have, the marketplace, probably you guys know that. Some vibration sensors that, not only vibration, but temperature and other variables that cost maybe $10 each. So it's significant, and with Bluetooth Wi-Fi capabilities, this is just one example. And this is a very interesting example. So this is another success story based on the workflow that I showed to you guys in the previous slide. This is based, the sensor here was really computer vision cameras. It does feel like a very easy, process to be done. It's not complex, but you can nowadays, in the past I recall, it was very difficult to achieve or measure tolerances in components using computer vision. You used to use computer vision for big things or to monitor, let's say, presence of parts or track material handling and things like that. But now we can use even computer vision to determine quality of parts and components. And this example for pharmaceutical industry. And if you know pharmaceutical industry, sometimes 50% waste is very common, right? You have to consider this, let's say, under capacity or implement some kind of over capacity because of the tight constraints you have making pharmaceutical and compliance and liability and things that you have to consider in this process. So, but if you can minimize this, let's say 50% waste that for this specific company or product line could be 20%, if you can minimize that to 5% or 10%, that's significant savings, right? This is additional capacity that you're adding to your production. But for this specific customer, they use computer vision to assess the quality and tolerances of a product. And at the end of the day, they achieved accuracy of 99%. And I have some additional numbers here for you. Basically, they were able to, in 2 weeks' time, add to their, let's say production output almost 900,000 parts, and only reject 10,000 parts, adding roughly $2 million to the top line on sales because of that. So when I talk, just to summarize, when I talk quality, I'm not only talking about leveraging the existing data. Think about the outcomes, the objectives you want to achieve, and then later we assess how to get there. And technology has improved tremendously, that there are so many ways that we can start measuring quality. David, I know that you're also big on computer vision. Anything to add?
I am, and I think there's two discussions here. One, computer vision has come so far, and what you can do with it, and that the preciseness of it is really matured, and companies are continuing to work on how to leverage that into the production environment more and more, and so that is goodness. The other thing you mentioned, and packaging is actually an extremely large topic amongst customers right now, because sustainability is on everyone's mind. And when you think about quality, actually sustainability is probably one of the top items coming from the quality discussion. And so when you think about packaging and the effects of sustainability from a packaging standpoint, one, packaging always takes up a lot of space. And when you're not able to produce the right, yield or throughput from a packaging standpoint, from a quality standpoint, you get sustainability impacts immediately, not only from the scrap and waste from the packaging materials, but the downstream effect of shipping, energy, CO2 emissions, et cetera. And so because this has such a large downstream effect from I'll say first pass yield of packaging, this has become actually as focused of an area in manufacturers as equipment CO2 energy reduction, honestly. And so I think this is actually a great jumping on point for a lot of quality leaders to look at, hey, how are my investments actually driving the whole sustainability mission as well?
David, would you take us through the final slide?
I will. And so, we've been talking about predictive quality throughout this session and what that means. And what we're seeing is cloud in the manufacturing world is continuing to grow. And it started with predictive maintenance, it's moving to predictive quality. It's moving to hybrid MES environments, and you can continue to see the cloud being driven into the core operations environment. And there's multiple reasons why. One, it allows you to really enrich data from multiple sources and gather that, and not only look at a site, but be able to look at the ecosystem, be able to look at the enterprise, and be able to rationalize from those, better insights on how certain pieces of equipment run, how certain operations run, how certain weather conditions affect your operations, and what can be done about that. And by the way, just learning from the rest of the organization. And that's so much easier to do from a cloud environment and consolidating from a cloud environment. The other is really building this analytics pipeline, using various languages and built-in autonomous operations and explanations to get those better insights. And then, finally, the decisions that are coming out of that. So this is one way to overlay the entire enterprise of manufacturing, or just a single facility, to get a better input, and output, honestly. And then what do you do with those decisions, and how do you feed those decisions back into the core operations? The other thing that we're seeing is this isn't, and a lot of people talk about cloud from a cost standpoint of taking out equipment and going to the cloud as a quicker or cheaper way of doing things. And really what we've seen is it's the flexibility that is the greatest benefit. And being able to do this multi-site analysis, being able to have SMEs centralized that can help each facility in a more impactful way, and then being able to learn from that larger ecosystem quickly and be able to align best practices across the company. And so this is where we see, things are continuing to move and get better. And it's real today. And I just would tell everybody to keep pushing this, because there's so much more that we can do. And sometimes, we don't push hard enough to say we need to continue to get better, or we need to think about things differently. And this kind of creates the art of the possible scenario of how can I rethink manufacturing from a higher level of quality, a higher resource output, and use this as the foundation without actually spending a lot of money, without actually having to, I'll say, rip and replace your manufacturing systems environment. This is an overlay of that, but it's an overlay that can have direct impact and direct connectivity back into those execution systems. And I think that's the important thing, is being able to tie this back into those execution systems so that you're constantly getting real-time feedback and moving the operations forward. So with that, I would like to take an opportunity to close out here and thank everyone for participating today. And I'd like to thank Vinicius and SAS for having me participate in this. And this is something I've been passionate about for my whole career. And we'll take the opportunity now to take some questions and do some Q&A. Julie, over to you.
Thank you, Vinicius and David. What a great conversation. Yes, just a reminder, if you have questions, go ahead and pop those into your dashboard there, and we'll take those. I see a couple, and they kind of circle around, why is quality such a hot topic now? Why now? You guys want to address that?
Yeah, I'll jump in on that one. And it goes back to, I think over the last 10 years, it's been so much focus on productivity, and just purely from a machine standpoint, how many OE conversations can we have? And I think what we've seen is, before the pandemic, there was just a lack of resources in manufacturing. And so every manufacturing plant was struggling every day to just have enough people show up to actually run production. And then because of demand and everything was so good, you didn't have enough resources to run overtime, run weekends, etc., or people were just so burnt out because they were constantly working nonstop because of demand. And then pandemic came, and now it's even harder to get resources. And you look across production environments, they've actually not slowed down, they've actually sped up in many cases. And so why quality is so important is because yield yield is the number one topic on every manufacturing executive's mind right now, is how do I get better first pass yield? How do I get better productivity? And quality is the answer to that. And times were so good and profits were so high over the years that sometimes you forgot about the quality side, because it only on the book sometimes it only shows as so much impact. But now when I'm missing sales because I can't get enough product out there, that's a big hit, and that catches the attention of every CEO in the world. And it comes back to, I need to get better yield, and the way to do that is really through quality improvements.
Okay, thank you, David. Vinicius, do you have anything to add?
No, just want to add that now we are living a situation of, let's say, over demand in the market, right? I mean, how can we ride this situation? And because it's the time really to achieve, profit and start making up and boosting our numbers, right? I've been asking many times, so how, I've seen manufacturing companies pretty much auctioning their products in the market and being unable to keep up with orders they are getting. So, if you can improve quality now, this is the timing to start, getting the benefits.
For sure. A couple of questions kind of around the how. How do we do this? One of those, how is predictive quality and process optimization different than a golden batch?
I can take this one. So, if you think golden batch is pretty much, you made a very good batch, right? Over the years, what a good batch look like. And then you pretty much freeze all the inputs, all the parameters, expecting that if you do so, you're going to have the same outcome that you had maybe a year ago, 6 months ago in the golden batch. But the golden batch doesn't account, like I said during the presentation, for deviations and changes in the process, or deviations and changes in terms of feedstock and raw material. So it's just, let's say, a reinforcement to the open loop manufacturing that I described before. So, and process optimization and better quality goes back to the closed loop, right? Where you are not assuming that the boundary conditions that you had in the golden batch are going to be there for the future. You're going to be getting this information in real time or near real time in order to improve what was a perceived golden batch to offset some of those deviations.
Okay, and that leads us into another question. Can that process optimization run in real time? You referenced in real time there. So can the process optimization run in real time?
I can take this one. Yes, it can run in real time, definitely. At the end of the day, it depends on your requirements, right? You can run in real time, or you can run in so-called near real time, or you can run in a batch process, right? Where you're optimizing your process every couple hours, every couple minutes, or days, or months. So because each manufacturing operation is a different operation, right? Some manufacturing operations, certain parts, the lead time is probably, let's talk like a gas turbine, right? We're talking about 6 months lead time to make a new gas turbine. Whereas if you're making, let's say, olefin, right? From the time you get, let's say, your feedstock to your, let's say, final product in a chemical operation, we are talking about 12 hours. And it's a continuous operation. So a continuous operation probably asks for, faster optimization. Whereas if you're making a gas turbine, right, we are talking probably weeks time or days time. So there's no silver bullet here.
Yeah, but to that, I would say that taking quality insights and turning them directly into equipment adjustments, in real time is something that's, more prevalent today. And if you think about certain machines in a process industry where there's, alarms going off nonstop, we've seen and we've, done some work with some customers where, we were able to reduce, alerts by 90%, on their equipment by understanding how they're operating through quality analysis and performance analysis, and then being able to feed that real time in to make, real time adjustments to the settings. And I think that's, that's the ultimate goal, is how do we take these, predictive quality and quality insights in real time, near real time scenarios and apply them into real time equipment adjustments so that we aren't losing or aren't reacting after the fact to quality. We're dealing with quality real time, and I think that's the opportunity here, with predictive quality and prescriptive quality, to be quite honest.
Great answer, and that covers the questions that we had. Do either of you have any closing thoughts before we go?
I just want to thank everyone for attending this webinar. I hope it was really fruitful for the audience here, and wish you all, a great rest of the week.
Wonderful. Thank you so much, David and Vinicius, and thank you all for attending. We'll go ahead and wrap this up now, and our host, IoT Solutions World Congress, will be following up shortly with the recording and on-demand version, and we thank them for their hospitality today. Thank you, everyone. Have a great rest of your day.
Thank you.